we're going to talk about the synthesis of primary amines. Primary amines cannot be made this way. NH3 plus, might as well use the example at hand. And you get something like this. And you get this. I mean, this reaction happens. It does, I'm serious. NH3 is going to be excess, just telling you. Otherwise, Br minus would be your base, which is not bad. I mean, it's not a good base. But NH3 is a better base. It just makes this reaction work a lot better. And you keep asking yourself, why does he keep saying you can't do this? And he's doing it. I mean, he's contradicting himself. I am. Yes, you successfully made this thing, which is a primary amine. But also a new. And it's going to hit up another molecule of, I don't even know if it's the right molecule yet. BRH does the same thing again, etc. The secondary amine, etc. The tertiary amine, etc. Quaternary ammonium salt. Oh boy. Quaternary ammonium salt. What the heck is a quaternary ammonium salt? Well, one, it's got another M, and two, it's got 4 R groups, R4N+. And in this case, the halogen would be a counter ion or a spectator. There's a salt. Cation, anion is a salt. A salt. Okay? So if you want the primary amine, you'd say, well, I'll just use stoichiometry and keep the, 1-to-1 ratio here. You're going to get a mixture of all the types of amines. It's hard to control because the nucleophiles all have about the same nucleophilicity. So who says which one's going to react second? Is it the ammonia or is it going to be another molecule here, this nitrogen? Which one's going to be the second one? I don't know. They're both about the same nucleophilically. This top reaction here is what I call, and it's not the first time, a dog's breakfast. Do you remember that? It happened when we tried to do a mixed aldol reaction and we got 4 products. Not a good situation. All right? Mixed Claisen, same story. So we did directed aldols and directed Claisen. That was the solution. Here, the solution is don't do it this way. If you want a primary amine, do what we're about to do in the activity. It is the protocol that gives you a primary amine with very nice yield, like in the 90s. It's very good process. So you start with an RX that is secondary, in this case. Secondary RX. Now, this is where my students taught me a word in Arabic. I asked them, I literally asked them, well, how do I say, I don't know? And they said, Mabarif. Yeah. So you say Mabarif this way, SN1, SN2, question mark. We don't know when it's secondary, right? And then you go to 2, your nucleophile, is azide, which is strong. Now, what are you thinking about? Which reaction does stronger nucleophile speed up? Well, it's the one where the nucleophile and the RX are involved in the rate. They're hitting each other. Well, nucleophile is the hitter, right? So, yeah, you said that. SN2. Two molecules reacting with each other. And then 3 is going to make sure this thing does an SN2. Solvent, DMF, curious, dimethylformamide is right there. Dimethylformamide. And it's polar and aprotic, no protons on nitrogen or oxygen. Also says SN2. Our conclusion is SN2 because those two things are saying SN2. And you better do an SN2. Didn't ask for the mechanism, but here's the mechanism free of charge. No triple bonding. N double N minus with a lone pair. 2 lone pairs if you're keeping track. Just need 1 for the SN2. Well, a little lazy on that mechanism. Want my red arrow. Won't give it to me. So let's do it. What's the easiest way to draw an SN2 product? You copy. You got the wedge and the dash. The nucleophile came in from the back and changed color to blue. And H got pushed out in the backside attack. And that thing right there is R. And now we need a way to do this reaction. The amine, R3-octanamine, is drawn right up here. The arrow should go the other way. And it's got an NH2 up there. So take a wild guess. Well, before you take a wild guess, what general category of reaction replaces bonds from more electronegative nitrogen to less electronegative hydrogen? What's that general reaction type called? It's a reduction. What's your first guess for reduction in this class? And it should be, if it's not, what should be your first guess for reductions in this class? Because we've seen this chemical reduce at least 10 functional groups by now. Lithium aluminum hydride and HCl follow-up. In this case, or H2PT also can work. And we need options for nitrogen because sometimes our first option doesn't work. H2 and nickel again. Okay, kind of reminds me of the nitro reduction. 3 out of the 4 are here. The nitro reduction to NH2 also had a tin one with HCl. There's a 4th one there. You should study them together. Reduction of azide, which is this one, and reduction of nitro, which is all over the textbook and videos. It's a very important reaction. RNO2 goes to RNH2 is just as important, maybe a little more. And same methods here will work. So same as above. And you put a above. Or a 4th method, tin, comma, HCl. There you go. You got all your reduction of nitrogen review on one page. Okay? So that's a primary amine from a nitro. And here we have, above, we have a primary amine from an azide. Okay, so we keep reminding you it's a primary amine from an azide. And since we're on the topic, I do want to remind you, you did know a method to make a primary amine, a very reliable one earlier, and it's the reduction of an imine. So since we're on this page is going to be all about primary amines now. And let's review. Imine reduction can give primary or secondary amines. It just depends on which structures you're reducing. First of all, we should remember how to make an imine. If I do NH3 or NH2CH3, and I throw a little DST at it, just to make sure. What kind of reaction does DST help with? Condensation, and yes, you're getting rid of the O and two H's. Two of the H's are gone from nitrogen, the O is gone from the carbonyl, and you have an imine. And down here, you also have an imine. Oops. Also an imine. You can do two methods here. You can do H2PT. Oh, what the heck, I'll give you three. Or one, your favorite that you always guess with. Or this is one where the sodium borohydride also works. There you go. And guess what you made? You want to see the two new H's? There you go. Primary amine, as promised. And similarly, ditto. See what I'm saying? And in this case, you also got a primary, no, you don't. Notice the title says you can make secondary amines. Here it is. CH3. Don't turn the page on me. Thank you. There we go. Secondary amine. And that's not a new reaction at all. In fact, the process had a very fancy name and it looked like there's some dyslexia involved. The first word was reductive. And what functional group are you making? Amine. And making is like process thereof, put a ation at the end. Yeah, it looks, amination looks like animation is what I was going with the dyslexia thing. Okay. Reductive amination is a very common and cheap way to make primary amines and secondary amines. If you want the tertiary, since we're here, reductive amination from an enamine would give a tertiary. You ready? Tertiary from reductive amination enamine, involving enamine, involving. What's he saying? I don't know. We'll go with a new one. And you just got to start with a secondary. There you go. And that's gonna, with a DST, it's gonna make this condensation product happen. Oh, the nitrogen changed color. Ethyl, isopropyl. That's an enamine, right? Enamine. And same dittos. Ditto, ditto, ditto. Any of those three methods is what I'm trying to say there. And you're going to get this tertiary amine. Tertiary amine. And just to prove that reductive amination is a cheap and reliable method of making amines, I just need you to rewatch Breaking Bad, where Walter White uses reductive amination to make methamphetamine. And end of that story. That's enough. Okay. The short little activity ended up being not so short.